There it goes. Okay. Today, homework questions. I'm going to cover odds, and I'm going to go into 5.5. Now, this is toward the end of the unit, so that means that probably Thursday, homework questions and pretest. Okay? So that means that Thursday, I'll put the dates on the test and the homework. So for some of you that have procrastinated and haven't done any homework, yes, there are some people in here that haven't done any 4.1 homework or any chapter 5. And just remember, and I have to do this because I've got people in both the 120s that are not doing any homework. And I know what they're thinking. Some of them might be thinking that, well, I already know this because I was in high school and I took it, and I don't need to do the homework. Well, that's 20 points off your final grade. So whatever you get, that's 20%. Homework is 20% of your grade. If you don't do the homework, that's 20 points taken off your grade. So that means that the highest grade you can make is an 80. Okay, so I don't want anybody giving me that, I didn't know that, at the end of the semester. This isn't Autopilot 101, and I told this to the 120 class yesterday. You don't just come in here and do what you want to do and expect to get the grade that you want. You've got to follow directions, just like the students that didn't have Math 120 in high school or probability and statistics in high school. So I hate to be kind of a parent here, but, you don't do things the way you do them. You do things the way your supervisor wants you to do it. And, I'm just talking to the minority here because I've only got several students that haven't done any homework. So I don't know what the deal is there. Maybe y'all can explain that to me. I don't know. But out of, let's see, I think I've got 20 students in this class and 15 in the other. That's 35 students. Out of 35 students, I'm talking about 5 students or less. So I don't know what's going on there. All right, so now we're going to go over homework questions. And I've got several. Ooh, this one just, okay, this one is, we got 4.2 questions and 5 questions. So I'm going to try to hit just the 120-29 questions, if you don't mind, since this is 120-29. First question is 4.2, 13/5. 4.2, 13/5. What? Let me try it again. I don't know what's up with. There we go. Okay. The least squares regression equation is blah, 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 where y is the median income and x is the percentages of 25 years and older with at least a bachelor's degree in the region. The scatter diagram indicates a linear relation between the two with a correlation coefficient of 0.77. Complete parts A through C. Now, I like parts of this question for a test question, but other parts I do not like. I think there's one part, I think we did this question, I'm not sure, but there's one part that doesn't make any sense. Let's go ahead and write down the information that they give us. The information that they give us is the formula, which is the most important. The equation is the most important. So their line of best fit is y equal to 721.9x plus 14,175. And somebody has a question or a comment. Let me switch over to and see what that is. It's not allowing me to click on the video. Oh, you're talking about your camera, Miss Richardson? I don't understand. Oh, it's not allowing her to click. I don't understand the question. Miss Richardson, are you in the classroom? Yes or no? I don't know what she means by click on the video. I don't understand that.
I think she means she can't get into the, like, this call.
Okay, let me see if I can invite her. Well, I don't see her, so I'll just type in Richardson. There she is. There, see if it will call her now. Give her a second to come in. Miss Richardson, are you there?
I'm here now.
Okay, good. I sent you a call. I don't know why it wouldn't let you join, but thank you for being here this morning. Okay, so we got 18. That's good. And I know one person, Miss Dennis, is not going to be here this morning. She's got other things she has to deal with, so she's not going to be here this morning. Okay, so let me go back to the question. And I don't know why this autofocus is not working. There. All right, that is the trend line for all those points. Okay, so that line looks like that. This is the equation for that line. And it's got an R of 0.7745, which is pretty strong. Okay, and that means it has a positive slope. And we see that right here because that number doesn't have anything in front of it, so that means it's a positive. So that's the information they give us. Now the bottom tells us the percent of bachelor's degree somebody has. So this is 15%, this is 20%. Now, it says right here, I want you to read this. It says, Y, the median income, this is the income. The scatter diagram indicates a linear relation between the two variables. Okay, here we go. X is the percentage of 25-year-olds, years and older, with at least a bachelor's degree. Okay, I need you to read that to yourself. X is the percentage of 25 years and older with at least a bachelor's degree. Okay, the percentage of 25 years and older. So X is equal to percentage of 25 years or older with a bachelor's degree, BA/BS. Okay, so now they're going to ask you some questions. Predict the median income of a region which 20%. Okay, so you're going to type in 20 into this equation. So that's going to be at F of 20 is equal to 721.9 times 20 plus 14.175 or 14,175. So we're going to take out our handy dandy calculator And I'm going to move it over here and pull the question back up and move that. Give me a second to get this fixed. I'm trying to fix it for y'all. There we go. There. So 721.9 times 20 plus 14,175. So with 20% of the people having a bachelor's degree or better, they're going to make $28,613. So we pull up our handy dandy answer, and it should be 28,613. In a particular region, 28.5% of adults, 25, the median income is the region is 31.5. Is this income higher, or would you expect? So now you're going to type in 28.5. I'm going to 28.5. So F of 28.5 is equal to 721.9 times 28.5 plus 14,175. So they'll go back to our handy dandy calculator, and let's see, second enter. There we go. 721.5 times 28.5 plus 14,175. I got 34,749. 34,749. So let's go back to our question. Now, they said in a particular region, 28.75 adults, blah, blah, blah. The median income in this region is 31. They went through and got 31.512. Okay. Is this income higher than what you would expect? Well, our income is 34,749. So now I don't like this B question because of the way they ask it. They say this is blank than expected because the expected income is, and we would say 34,749. I have to read the second part of this question to understand what they're asking for the first part. That tells you that the question is not written very well. Okay? We just figured the expected income. All right? Now, if I'm reading this right, I may have it backwards. It's more, this is less than expected. See, I'm confused with the word this. Okay? Does anybody see what I'm talking about here? Just raise your hand if you understand what I'm talking about on the way this question is worded. Anybody? Okay. I at least have one person. All right. I don't think the question is worded. This part right here, this. What the hell is this? Does this mean, are we comparing 34 to 31? Or are we comparing 31 to 34? So I guess if I'm missing something here, I don't know, okay, because I can go higher or lower, okay, because if I say this is higher than the expected income is, I think we just found the expected income. So that means that this is lower than the expected income. That's the way I'm reading it, but this is not a good, I don't like the way this question is worded. We got it right. So I don't know if you had a question with that one, but that part right here is confusing. Interpret the slope. Select the correct choice below. Well, our slope is 721.9 times x, or 721. So that means for every notch of experience, our curve is going up 721.9. That's what slope is, okay? So for every tick mark on the x, we're going up 721.9. So some explanation of that would be for every tick mark, you're going up $722. So I don't know which one of them says that. It's not for every dollar increase. That's not correct. Because this is not dollar increase right here. This is bachelor's. Okay. For median, no. Okay, C and D mentioned bachelor's first. So that might be the answers. For every percent increase in adults having at least blah, 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 the median income, I think is C, 721.9. Okay. Oh, God, how many parts does this thing have? Explain why it does not make sense to interpret the y-intercept. Well, the y-intercept would be 0 bachelor's degree, 0%. Okay, I don't think you're going to have 0% bachelor's degree in this field. Okay, because it starts off at 15%. So I think anytime you see outside of the scope, that's probably going to be the answer. So you got 2 outside of the scopes. It does not make sense to interpret the y-intercept because the next value of 0 is outside. I think, let's see. Yeah, x value of 0, because that's the y-intercept. I think that would be the answer. The only part of this question I don't like is this right here. I understand the expected income. I don't like that part right there. What they're asking you to do is compare that 3155.12 to this number. And I understand what they're asking. I just don't think this is written correctly right here. Hopefully that helps. Let me turn this off because I'm going to turn my video off because I might be saving some space here, bandwidth. Does anybody have any questions on this one? So is this a test question? I would say it is several test questions, but I would not put this on the test because of this right here. I don't like that. I don't like that. But I do like this question. I like A, I like C, and I like D. So the only one I don't like is B. Now let me ask you a question. I don't know who sent this question. Let me look and see. And I want to ask you a question. Miss Scruggs, are you here? Oh, let's see. Yeah, she's here. Miss
Yes.
Scruggs, you here?
Yes.
What part of this question gave you the most trouble?
All of it.
All of it? Okay. Well, does this help?
Yes.
Okay. And B, that I thought the reason I was asking was I was wondering if B, if you had the same contextual problem I had with this first part of B. I just wondered if you got stumped there or not. Okay. All right. So that's that question. And I'm going to delete that one. All right. This is 24. That's 24. That's 24. That's 24. Okay, this one is 5.2 7/4. 5.2 7/4. I don't know what the heck. Has anybody seen this lately? I don't know what's going on here. Has anybody had this coming up on their computers?
No.
I don't know where it's coming from. Let's see if it comes up. Let me go back and hit it again. Come on, don't start this morning. I really don't feel like this. I already don't feel good. That's why we're having class today. I'm not feeling too good. And it ain't got anything to do with Rona. I don't have respiratory problems. Let's see. What the heck? Okay, it said the site cannot be reached, and then it puts a question up. A probability experiment is conducted in which the sample space of the experiment is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Event F is 5, 6, 7, 8, 9, 10. And event G is 9, 10, 11, 12. Assume that each outcome is equally likely. List the outcomes for F of G. Find P of F or G. Or, what does that mean? Or means what? Additive law or multiplicative law?
Additive.
Additive law. So you know you're going to use the additive law here. Counting the numbers of outcomes for F or G, determine F or G using the general addition rule. Well, why in the hell didn't they just say that instead of all this? Anyway, I'm sorry. So first of all, I want to show you something here. I like to tell students to use the Venn diagram here. You got two sets. Now, for some reason, some of y'all may remember stuff from the first and second grade, but when I was in the first and second grade, I remember doing sets like this. Set A and set B. In this instance, it's set F and set G. Okay? And in this set, in set F, we got 5, 6, 7, 8, 9, and 10. And in this set, we got 9, 10, 11, 12. So if we was to draw a Venn diagram of F and G, we would get 5, and the only thing in common is what? 9 and 10. So we would get 5, 6, 7, 8, and 11, and 12. So I just want to show you that, because what do we always have to remember with the additive law? Always subtract the what? We went over this in class. Somebody needs to interact with me.
The overlap.
The overlap. Thank you. And somebody has a question or a concern, and it keeps kicking me out. We don't want you in here, Miss Peters. I'm sorry. Miss Peters, are you still in here?
Yeah, I'm back now, but like it keeps like my screen will go black and then it'll say looks like there's a problem or something, and it tries to connect me back, but I'm back now.
It may be your wireless. I don't know. Are you Are you at Clemson, or are you at an apartment, or what? Where is your location?
Yeah, I mean, I'm just at my house, like in Anderson, but I don't know, it's weird. But it's working now, so keep going.
Okay, I haven't heard anybody have any problems like that the whole semester, so it may be just something fluke at your wireless or wherever you are, or your wireless provider. Well, who do you have wireless with?
I think AT&T, and they've been having problems like yesterday.
Yeah, I have too. Yesterday, my AT&T kept cutting in and out because it might be maybe your problem, because some of my students said that my hand was freezing up, when I was writing.
Yeah.
So that it may be the same thing with you, only it's kicking you out.
Yeah, true.
All right. So anyway, it says list the outcomes in F or G. It says what is list the outcomes. Well, I think we just did that, but I don't know exactly how they want it written. F or G should be right here. Should be 5, 6, 7, 8, 11, or 12. Okay, but I don't know what they're wanting, so I'm just going to hit 3 because I don't know if they're wanting the overlap or if they're wanting what makes up the 2. So, okay, they're wanting what makes up the 2. So there's 5, 6. Okay, so they're wanting this. Hold on. Let me get it back here. They're wanting this, or this right here. 5, 6, 7, 8, 9, and 10 overlap, so they just write it once, and then 11 or 12. This is not a test question. Okay, I'm gonna go ahead and tell you that right now. This is not a test question. Okay, because this question is confusing to students. Because one, the whole paragraph up here is too wordy. Okay, they say list outcomes of F or G, find F or G, and then determine F or G. They've done 3 things right there, and that's not necessary. Okay, find F or G by counting the number of outcomes in F or G. Okay, well, this is the number of outcomes with F or G. So I don't know if they're wanting the number, but they could be saying 5, 6, 7, 11, and 12. 5, 6, 7, 8, 11, and 12. I'm just going to put 3. I'm not typing all those in. Okay, here we go. They want the actual probability. So that's going to be the number of, so that's going to be, let's see, how many we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 here. 1, 2, 3, 4, 5, 6, 7, 8. Maybe 8 out of 12, which is, let's see, 8 out of 12 would be what? 2/3? I'm thinking. I don't know. 2/3 maybe. And I got it wrong. Okay, I'm sorry. Somebody take 2 and divide it by 3, and you should get 0.667. Let's see what the directions say there. Okay, I didn't read the directions. Type a decimal. Okay, I didn't read the directions. Sorry. Determine F or G using the general addition rule. Select, okay, that would be, let me go back to I don't like this question. All right, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we got 12. And this is going to be 1, 2, 3, 4, 5, 6. 6 plus 4 minus 2. Okay, 6 plus 4 minus 2, because we got the overlap right here. 6 plus 4 is 10. 10 minus 2 is 8, right? And that's 1, 2, 3, 4, 5, 6, 7, 8. So I guess that's what they're wanting. So it should be 6 plus 4 minus 2 is 8. Okay, and that's why I draw this so you can understand it. Always subtract the overlap. Now, they're showing you the addition rule exactly 180 degrees from the way I showed you. Okay? This is a terrible example of the addition rule. So if you are confused by this example, I understand why. I would not put this on the test. Okay? See, I even got it wrong. I don't know what else they want because, oh, they wanted the probability of each. Six over 12 is 0.5. 4 over 12, I mean 4 over 12, not 4 over 12, 6 over 12 is 0.5. I don't know, let's see. I may have these right here. But 8 over 12 is 0.667. So they got the same answers. They just want decimals. So you would put 6 over 12 is 0.5 and go that route. This is not a good question. I'm not going to spend a lot of time on this one. I'm sorry if I don't, but I don't want to spend a lot of time on questions I'm not going to ask on the test. All right, I'm going to get rid of that one. All right, this is 24. That's 24. Well, now my computer's running slow, Miss Peters. I don't know what's going on. Okay, this shouldn't be taking this long. I've been getting these. I don't know what's up with these little frowny faces. And y'all haven't been getting any of this. You've been getting this. I don't know what's going on. And then you click on it again, and sometimes it comes up, sometimes it don't. Has anybody seen this on their computer?
No,
Anybody?
I haven't.
Yeah, I'm sure people are trying to steal my homework question emails. I don't know. I don't know what's going on, people. I really don't. This bothers me right here. This tells me that I've got problems. Let me hit refresh. Email. 120. Okay. I don't know if this was it or not. Is this the one we just did? Let's see. Thought I deleted it. Oh my gosh. I'm reading. I don't know. I'm not going to hit advance. Let me hit this one right here and see if 24, 24, 24, 24. Okay. Y'all don't have any other questions except for this one question. And I can't remember if we did that question or not. I think we did, but I'm trying to get to it. Okay, I'm going to have to find this out after class. I'm going to have to call AT&T and ask them what the hell. This is starting to get on my nerves. All right, let me just go to what we're going to do today, and that is the odds. Let's get that done. Sorry about this. All right, so odds. I think this is in I don't know. I didn't see it in the slides, so I don't know where it is in your book. If somebody finds it, please speak out and let me know. But we really care about odds against. Odds against is what's used in gambling. And I don't know if gambling has the E in it or not. I can't remember. I'm very bad about the words that drop the E with ing. I can't remember all of them. So if I got it wrong, please let me know. Odds against is usually what we use with gambling. And odds against, I'm going to write down two things in pink, so that means it's important. Number one, always use fractions, because the fractions will cancel. Okay? So it's easier, and that pink is dead. Fractions, always leave them in fractions form. And let me get another pink. And now I'm out of fluorescent pink. Shoot. Hold on a second. Let's see if this pink, I'm gonna have to get another fluorescent pink. Okay, and two, when you use odds against, you always want to use that number, the number you get, it's usually going to be a decimal, to multiply by your bet. So if you bet $500, you want to take your decimal that you got with the fractions and you want to multiply by your bet. That's what odds against does. And I guess I'll have to use another fluorescent color. The odds against is the probability of failure over the probability of success. And the probability of success, usually success is given by the problem. The question will say, what is the probability of picking a king out of a deck of cards? Okay, that is success. So if the question says, what is the probability of picking a king out of a deck of cards, then that is your success. And what is your failure? The probability of not picking a king is your failure. So usually when the question is asking, whatever the question is asking, usually is the success. And you just have to find the complement, which is not successful. Now, I'm just going to make a note here that your odds in favor is also asked on, not in my test, but on standardized test in your homework. And I spelled that wrong. Odds against is the reciprocal of odds odds. I think I'm losing my mind. Odds favored, odds in favor, thank you, is equal to the reciprocal of the odds against. So I'm not really concerned about the odds in favor, because if you can find the odds against, then all you got to do is flip it, and that's your odds in favor. Okay? It is the probability of success over the probability of failure. Okay, so odds in favor is equal to the probability of success over the probability of failure. Now, I'm not really going to concern myself with this because, like I said, if you can find the odds against, you can just flip it and that'll be the odds in favor. All right, so the question that you will see that I show in my notes is what's called the roulette table problem. And I ain't even going to say that I know how to spell roulette. I don't know if it's got, I know it's got 2 T's in it, but I don't know if it's got 2 L's in it. So I'm not going to. Roulette table. Somebody check it for me and tell me if it's got 2 L's or 1 L. All right. The roulette table looks like this. It's a circle. And it has another little circle inside of it. And has slots.
New Facebook comment.
All the way around it. Okay. And you got a rail that sends the marble around, and then the marble goes this way. And then the wheel goes this way. Okay, there's a rail on the outside of the wheel that the marble goes in. It's like a track. And it spins it around, and then the wheel spins the opposite direction. And when both of them slow down, gravity takes over, and the marble does what? Falls in one of the slots. Okay? This is 100% chance. There is no way, unless you use magnets and a steel ball, or steel, have a, you know, some kind of steel or under the table with a magnet, there's no way to cheat with this unless you actually use magnets or some form of magnets. Okay, so what's the table numbered? Well, it has a, I'm going to do this in ultra green. There's a green 0 and a green 00. Okay, and then the rest of them are numbered 1 through whatever, and they are black and red. Okay, so they're colored in black and red. So I'm going to put a red here and then a black. And it's numbered red, black, red, black, red, black, red, black. So I'm not going to go through coloring all of the roulette wheel, you know, slots. Okay. In fact, I'll just do it the easy way, and I'll just do this. Since y'all didn't check and see if I spelled it right, I'll see if I spelled it right myself. And I appreciate y'all helping me out. None. Roulette. Okay, it's 1 L. Thank you, class. I appreciate y'all's interaction. Y'all suck. All right, there we go. Roulette wheel. And let's go to images. There you go. So does everybody see it? That's what a roulette wheel looks like. There's your 0 and 00, and then your numbers are all around, and they're not in order. Okay, you wouldn't want them to be in order on a gambling. There's another. Here's a good example. 3D. There's the rails. Here's the rail that the marble. There it is. See it right there? And it's going in one direction, and then this was going in another direction. And when it slows down, gravity plops it into one of these slots. Y'all with me? Good. Thank you, class. I appreciate you trying to respond, Miss Cameron. Thank you very much. Okay, rest of y'all suck. All right, so here we go. And I'm going to bet a $500 bet. $500 bet. And that's what the bet's going to be on all these questions. I'm going to do like 3 questions. All right, what is the probability, or what is the odds against What are number A? We'll do A. What are the odds against an even number? Okay, and let me give you what the slots are. All right, the slots from 1 to 40. So that means that there's 42 slots. These numbers right here, okay, are from 1 to 40. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way to 40. And then you got 0 and double 0. So the total is 42. Okay. Now, let me tell you something about these numbers. Well, half of them are going to be even and half of them are going to be odd. 0 and double 0 are neither odd or even. So write that down. 0 and double 0 are usually not odd or even. 0 and double 0 are neither odd or even. So we'll put a, okay. Okay, Miss Hall, you have to leave. That's fine. Just catch up with the, wait a minute, that was that out of this class? Hold on a second. Or was that, hold on a second. Oh, okay, that's from another class. Okay, I'm sorry. A student from a next class was telling me something. Let me know if you run into problems. It was telling me that she's having to, sometimes her teacher goes over and she has to get back to the apartment to call in. Sorry about that. Okay, so let's get back to what we were doing, and we are on the, in here. Okay, so make sure you make a note that 0 and double 0 are usually not odd or even. So what you would do is you would say, okay, I want to know the odds against even. So that's winning. This right here, even is winning. That's success. So the probability of even is going to be probability of success. And that's going to be 20 out of 42. Okay. Therefore, probability of not even is equal to 22 over 42. Okay, now I want you to write that down because this is very important, because this is your probability. I got to use pink, I'm sorry. This is your probability of success, and this is your probability of failure. So if I'm going to find the odds against, I'm going to put probability of failure over the probability of success. So odds against is going to be 22 over 42 divided by 20 over 42. And I'm going to multiply by 42 over 20, and the 42s cancel. And that's supposed to happen. That's why you leave them in fractional form. So the odds against are 22 to 20, which is, go ahead and break this down to 11 to 10. And you're going to multiply 11 over 10 times 500. So let's multiply 11 over 10 times 500. 500 or 11 divided by 10 gives you a decimal of 1.1. And you're going to multiply that times 500. That gives you $550. What's wrong with this? You're in Vegas and you're gambling and you just won $550 on a $500 bet. Yes, Miss White, do you have a question?
Yeah, I was just confused on how you got 20 and 22, and then the multiplication.
Okay. The 20 comes from 40 divided by 2. Because if you have 1 through 40 numbered, half of them are going to be even, and half of them are going to be odd. So that's where the 20 comes from. Now, what is 42 minus 20? 22. So that's where those two numbers come from. All right. The 20 comes from 40 divided by 2. So if this was 36, 1 through 36, then it would be 36 divided by 2, which is 18. If it was 50, if this was 1 through 50, then it would be 50 divided by 2, which is 25. Okay? Does that help you figure out where the 20 and the 22 came from?
Yeah, I understand the 20, and then you said 22 came from, what'd you do again?
42 minus 20.
Okay.
42 minus 20. It's always going to be those two. You're going to take half of how many slots you have, and then the complement is the number of slots that are not even, which is going to be, if 20 are even, then 22 are not even, because there's 42 slots. So you just subtract 42 or 20 from 42. Okay, you got it?
Yes, thank you.
Okay, any other questions on that? Now, I was asking, what's wrong with this number? Come on, people. I know I got some gamblers out there. What's wrong with $550? Y'all going to tell me y'all going to go to Vegas and y'all going to put down a $500 bet and you're going to get $550, and what's your reaction? What would your reaction be to winning $550 on a $500 bet?
Not great.
It's too low.
Exactly. There you go. Miss Cameron says not great. Mr. Lott says too low. Why is it too low? Because the probability is high. This is low because the probability of success is high. Therefore, the odds against are low. Write that down because that's very important. The reason you have a low bet is because somebody tell me what 20 over 42 is. Well, let's do it. 20 divided by 42. You've got almost a 0.5 probability of winning this game. What does Vegas say about a probability of 0.5? If you were a casino owner and you brought up a new game and you found out the probability of winning is 0.5, what would you say as a casino owner? Y'all don't have any idea what a casino owner would say. That means for every 10 people that play at my casino, 5 people are going to win. Is that good or bad for a casino owner? That's bad. 0.5 probability is too high for a casino owner. Okay, let me ask you this. What's your probability of winning the lottery?
Isn't it like 1 in a million or something?
1 in 292 million. Very, very, very low. Vegas casino owners want the probability to be very what?
Low.
Very low. Thank you. I appreciate you, Miss Cameron. Thank you very much.
You're
All right?
welcome.
They want you to be very low because that means they take in a lot of money. And money makes the world go round. All right, let's change it. Let's do the same problem. And this time, I'm going to fold this in half. Let's take the same problem. And this time, I want you to give me the probability with a $500 bet, the probability of hitting that single zero, and find the odds against. So the probability of success is the marble falling on the zero. And then the probability of failure would be not hitting what? Zero. So the probability of hitting zero is 1 out of 42. So somebody tell me what the probability of failure is.
41 out of 42.
Thank you, both of you, 41 out of 42. So the odds against is going to be 41 over 42 divided by 1 over 42. So I'm going to multiply by 42 over 1. And my odds against are 41 to 1. So I'm going to multiply 500 times 41. So I bet 500 and I win $20,000. What is your reaction when you win $20,500? You're in Vegas and you just made a $500 bet and you just won $20,000. What is your reaction?
That's some good money right there.
Thank you. I appreciate your interaction. That means that you're excited. Okay? Now, what changed? You still played the same game, same marble, same roulette wheel. What happened? Well, let's do 1 divided by 42. My probability of winning instead of 0.5 is 0.0238. So my probability of winning went down to 0.02. If your probability is low, if your probability of winning is low, then your odds are going to be high. If probability of winning is very low, odds against will be very high. That's the opposite of what we wrote in red on the previous page. And that's right here. Okay, if the probability of success is high, your odds are low. And therefore, this is what you won. You won $50. If the probability of winning is low, then your odds against will be very high. And instead of winning $50, you win $20,000. And that is how you do odds. So let's recap.
I have a question.
Yes, ma'am.
When you were multiplying, why'd you put 1/42, like on the bottom?
Right here.
Yeah, 1/42.
What is the probability of, what's the odds against? Hold on. What's the odds against? Probability of what? Probability of failure over the probability of what? Success.
Oh, okay, I see now.
Okay?
Okay, thank you.
Okay, in fact, I was fixing to go over that again. So hold on. So here we go. Odds against is equal to the probability of failure over the probability of success. And we'll add some notes. 1, keep in fraction form in order to cancel. Okay? And I showed you that in the 2 examples we just did. All right? The answer, I don't care what you write the answer in. If the directions tell you to write it in fraction or decimal, that's up to, you and the directions. But when you're doing the work, keep it in fractional form so you can cancel those numerators and denominators. All right? Second thing, the odds in favor is the reciprocal of odds against. And I don't really care about odds in favor, but it's the probability of success over the probability of failure. Okay, that now a homework question may ask you that, and a standardized test question may ask you for this, but I'm not going to ask you for the odds in favor. I'm going to ask you for the odds against. And 3, if probability of success is high, that means the odds against will be low. Therefore, your payout on your bet is going to suck. Okay? So if your odds or if your probability of winning is high, your payout is going to suck. Think about it. When you go to Vegas, there's the nickel slot machines and there's the dollar slot machines. Which one will you win most on? You'll win a lot on the nickel machines because you're not putting much money in it. Okay? You'll win bigger, not more. You'll win bigger on the dollar machines because you're putting more money in. Okay? There's an old adage, one of the truest sayings ever made. Nothing is what? Nothing is free. Okay? If you put in nickels, you think, oh, I'm going to win. I'm going to win. Yeah, you're going to win a lot, but you're not going to win a quantity. You're going to win number of times, but you're not going to win quantity-wise. If you put in more money, the payoff will be higher. Okay? If the probability of success is high, meaning the nickel machines, then you're not going to win as much. But if the probability of success is low and you use the dollar machines, your payout's going to be better. So if the probability of success is low, then your odds against are going to be high. Therefore, your payout is going to be great. Okay, so there's the recap of what we just talked about with odds. And that saying right there is one of the truest statements that I've ever been taught by my father. Nothing is free. Somebody always has to what? Pay. Somebody's got to pay for something. The casino owners, they have to pay for that money that's being, shelled out. Okay? They have to organize it so when, all that money comes in, they have to have it in a pot so that way when somebody does win, they can cover it. Okay? Nothing is free. You can apply that to many things in life. No comments? Gosh, I thought I'd at least get a comment out of that. No comments whatsoever. Y'all just going to stay quiet, not talk. 5.5. 5.5 is called counting. Now, everybody knows how to count, but what they mean by counting is by using factorial and exponents. Factorial and exponents. Okay? Factorial looks like this. And of course, exponents is like 2 to the third power is equal to 8. Okay? So we're using these when doing probabilities. One of the most famous ones is this. Give you a word. Let's think of the word. I'm trying to think of a word. Let's think of the word white. No, white's boring. Let's think of the word fandango. I have no idea where that word came from. Fandango. I don't even know what it means. Okay, fandango. Fandango is a word that has 1, 2, 3, 4, 5, 6, 7, 8 letters. How many different arrangements of these letters can I make? Well, that is called 8 factorial. The number of letters, factorial. What is factorial? Factorial is multiplying numbers in their sequence down to 1. Okay, so here 8 factorial is going to be 8 times 7 times 6 times 5 times 4 times 2, 3, times 2, times 1. You can do it on your calculator by saying 8, math, probability, and enter. Oh, I'm sorry. Factorial and enter. All right, so let's do that. Clear? 8, second math, second math. Well, that's not right. No, math, not second math, math. I thought it was math. So 8, math, arrow over to probability, and go down to factorial, and hit enter. So you've got 40,320 different arrangements of these letters. What about the word smile? I can't spell today. Smile. Well, that's 5 letters. So that would be 5 factorial. 5 times 4 times 3 times 2 times 1, and that's equal to 120. So there is 120 different arrangements of the letters in smile. Let's do that on a calculator. 5, math, arrow over to probability, and down to factorial, and enter. So I just went over 2 test questions right there. All right, what other test questions, or what other kind of questions will they give us in 5.5? Well, here's one called the license plate. You're making license plates. I don't know how to spell license because I always want to, is it SE? Is that right? I have a problem with S and C's in words. License, is that correct? Thank you for the input. I appreciate it. Here we got in South Carolina, I think we have 1, 2, 3 letters, and then 1, 2, 3 numbers. So letter, 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 and then number, number, number. So how many different license plates can I make with 3 letters and 3 numbers? This can also be done with alarm systems. Alarm keypad. Okay. So here we go. We got 26. We got 26 numbers, right? It's 26 letters. There's 26 letters in the alphabet. There's 3 slots. So that's going to be 26 to the 3rd power times 10 to the 3rd power. And time for the highlighter. This number, that exponent corresponds to how many slots? This number, how many slots? So if I had a license plate that had, and let's say Pennsylvania, and they had 2 letters and 4 numbers. then that would be 26 to the second power times 10 to the fourth power. So let's do that on the calculator. Caret symbol is this symbol right here above the division symbol. If you have another calculator that has x to the y, you would use that. So the first one is 26 to the third power, 26, x to the y, or caret symbol, to the third power, arrow over, times 10, caret symbol, or x to the y, 3, enter. So that gives us 17 million license plates. 17,576,000. And in Pennsylvania, clear, 26, x to the y, or caret symbol, 2, times 10, caret symbol, or x to the y, 4. In Pennsylvania, 6,760,000. And that's how you do the license plate question. Of course, we're going to see more questions. I'm just giving you kind of a rundown of what kind of questions you'll see. That's an exponent question. The first one we did, this first one was a factorial question. Now, there's two things in, and this is what I will test you on for sure. Combination and permutation. Now, you want the good news or the bad news? Which one you want first?
Bad news.
Bad news is the formulas for these are very tedious. I would like for you to find them in the book and write them down, okay, in your notes. Why? Just for the future. The good news is I'm going to let you do them on the calculator, okay? So where do you find them? Under math, probability, and you'll see NCR. Here, math, probability, and NPR. N is always your biggest number, sorry. N is always your biggest number, so if you're given a question, well, how do you know which one to use? It's real simple. This is in red, so that means it's very important. Combination or permutation is when you're dealing with something in what? In order. Combination means what? What's the opposite of order? No order. Now, these questions are really simple. They're going to give you, in this type of question, you're talking about the lottery. Okay, if I give you a question on the test, and it's a lottery question, it's going to be combination. These are going to be races, like a horse race or a car race or a bicycle race. What is the probability of first, second, and third place? That's order. And boards. with officers of president, vice president, chairman, vice chairman, whatever the case may be. Boards recognize officers, which is order. Committees do not recognize officers, which that would be no order. So let's say you have 39 numbers in the lottery and you pick 5. And how many different, what's the probability or what's the denominator? Because you got to buy a ticket, and we'll get into that later. So you would type in, we're going to get into these later. I'm just giving you kind of an introduction today. So that's going to be 39, math, probability, NCR, 5. So that would be 39, math, probability, NCR, 5, and enter. And that's going to give you 575,757. And the same thing with permutation. And you can do 39, permutation 5. I know you got to go. And I'm going to do it right quick for you. Same process, only you hit 39, math, NPR, or right there, and then 5. And that's going to give you a BA number, 69,090,840. Okay, so while you're finished writing that down, I need to turn everything off. I'm going to turn the recording off because some of y'all are like fidgeting. So that means class is over.